going to do some long division problems, division of polynomials. But let's recall how we do long division with regular numbers. Maybe 31 into 9, 4, 5, 6. We wanted to do that. Well, we noticed that 31 times 3 is 93, which is close to 94. That is, whatever number you put up here, you multiply it by 31, excuse me. That's what I did here. And whatever answer you get, you put there. And you subtract. Now you get 1. Bring down the 5. Realize that the largest number you can multiply 31 by and get less than 15 or equal to 15 is 0. So I put 0 up here. 31 times 0 I put there. Or a lot of you just skip that step and you bring down the 6. And then you realize that 31 times 5 is 155. So you put 155, you subtract, and you get 1. So let me put the 5 up before I forget. And the 1 becomes plus 1 over the number you're dividing by, 31. And there's no need to actually put the plus there. It's understood to be 305 plus 1 over 31. Okay, let me get this out of the way. Now we're going to do the same exact process, though you probably say it isn't, using polynomials. Keep in mind that this problem, I should have stated it as 9456 divided by 31. Calculate that. That would motivate you to do everything that we did. Now, suppose I ask you to figure out what x plus 2 into x cubed plus 2x squared plus 2x plus 1. How much is that? So, first thing you need to do is to compute x plus 2 into x cubed plus 2x squared plus 2x plus 1. And how you do that is you ask yourself x times what, and the what goes there. X times what gives you x cubed. And the answer is x squared. And like on the right, whatever we put on the top, we multiply by what's in front. What we put on the top, I multiply by what's in front. And I get x cubed plus 2x squared. And that's what I put here. X cubed plus 2x squared. And by design, the x cubes actually cancel. You know what? If you have 2x squared and 2x squared, and you subtract them, they also happen to cancel out. I like to bring everything down, that way you don't lose it. 2x plus 1. Now, it's a brand new problem. What do you multiply x by? And we'll put that answer up there. What do you multiply x by to get 2x? And the answer is by plus 2. Positive 2 times x plus 2 is 2x plus 4. And that's what I put here. 2x plus 4. Regardless of what people tell you, there's nothing wrong with subtracting. 2x minus 2x cancels. Positive 1 is 1, and positive 4 is 4. 1 minus 4 is negative 3. And that's the remainder. Negative 3 over x plus 2. Now, how do you know it's a remainder? The degree of what we're dividing by, degree of any polynomial, is the highest power of x, the understood 1. After we did some subtraction, our first subtraction, we were left with 2x plus 1. How did we know to continue? Because the degree was 1. And you continue until the degree is less than what's in front. Until the degree is less than 1. The degree of a constant is 0. The degree of a constant is 0. Why? Because you can always multiply the negative 3 by 1. And 1 is x to the 0. Why did I choose x to the 0 as a 1? Because there's the power of x now. The degree of negative 3. The degree of negative 3, since negative 3 can be written that way, the degree of negative 3 is 0. It's smaller. And that's the end. Negative 3 minus 3 over what we're dividing by. Now, let's consider that problem again. And we won't do it, but this has nothing to do, we won't finish the division, but this has nothing to do with synthetic division either. If the numerator is x cubed, I think it was, plus 2x squared plus 2x plus 1, and we're dividing this by x plus 4. X plus 2, excuse me. Now, that's the problem we did do. If instead it looked like this, that is, it's still equal. 2x plus x cubed plus 2x squared plus 1, all divided by, say, 2 plus x. Say this is what was given. When you start to do the long division, you're going to put something that equals 2 plus x in front. You need to write it from highest power of x to lowest power of x. The x is x to the 1. And the plus 2 is x to the 0. The powers of x's decrease. It went from 1 to 0. What goes in here, it also has to decrease. The degree of the numerator is x cubed. X cubed plus 2x squared, coincidentally plus 2x. Again, it happens to be plus 1. That's what you need to do. Worst yet, if you have, say, x cubed plus 4x plus 1, and you want to divide by x plus 2. Let's actually do that. You have to make sure that what's in front, the powers of x's are decreasing, and what's underneath here, they're also decreasing, but no missing terms. You can't have missing terms on the right. You cannot have missing terms here. We'll talk about what that means. In fact, I'll even change the problem just a little bit. Instead of dividing by x plus 2, how about we divide by x squared plus 2? So, what goes in front here should equal x squared plus 2. That's the highest power of x, 2, which is the same as 2x to the 0. It has the lower power of x. That is, if I write x squared plus 2, the power of x's went down. It went from 2 to 0. It went down. Now, in the numerator, or for the numerator, that is the numbers that go above the curly line I just drew, they must go also in decreasing order, the powers of x, that is. They must go down in order, but they can't skip any. And you have to understand things like 7 plus 5 is the same as 7 plus 0 plus 5. You can always add 0. 7 is equal to 7 plus 0x cubed. Because 0 times x cubed is 0, and 7 plus 0 is still 7. You can always add 0. You can add 0. You can take away 0 if you prefer. Okay, so what goes under the bar? Well, the degree of the numerator, the highest power of x, is 3. So the degree is 3. In this case, we have 1x cubed. You put the 1 if you like or not. It has no x squares. The numerator has plus 4x, and the constant is plus 1. We filled in the missing term, the the x squared term. We filled it in. Now, the problem starts. What do you multiply x squared by, and that goes there, to get x cubed? The answer is x. If you take x and you multiply it by x squared plus 2, you will get x cubed plus 2x. Actually, how can we fix this? How about we divide by x squared plus 2x? Excuse me. We divide by x squared plus 2x. Okay, still, x squared times what I put on top, namely x, gives you 1x cubed. And when we multiply by 2x, we'll get x cubed plus 2x squared. We get x cubed plus 2x squared. And we subtract this. X cubed minus x cubed is 0. We are subtracting. 0 minus 2 is negative 2x squared. Don't forget the rest. 4x plus 1. Now, it's a brand new problem. What do you multiply the x squared by, which is in the front? What do you multiply that x squared by to get negative 2x squared? Well, if you multiply x squared by negative 2, well, then you get negative 2x squared. Multiply by negative 2. Negative 2 times x squared plus 2x, well, it certainly gives you negative 2x squared. First we killed off the x cubed term. Now we're going to kill off the x squared term. And if need be, we'll kill off the x term. Minus 4x. Minus 2x squared minus 4x. And we are subtracting. When you subtract the same two values, you get 0. Because when you subtract, you find out how much bigger one number is than another. When you subtract, you find out how much bigger one number is than another. Negative 7 and negative 7. When you subtract, you'll find out how much bigger this number is than that number. Well, that's ridiculous. I know that already. It's 0. Okay, these are the same. You subtract them, you get 0. These are not the same. So when you subtract them, you don't get 0. You have 4 x's, and you are taking away negative 4 x's. Why, that's 8. That's 8. 8x plus 1. That one. Okay, the degree of this remainder is 1. The degree of what we are dividing by is 2. It's smaller. That means we stop. Okay. So let's erase this. It looks like an exponent maybe. So now it's plus 8 times, it's plus 8x plus 1. Plus 8x plus 1 divided by what we're dividing by. X squared plus 2x. Now, let's look to see why this helped us. It being putting in this missing term. Why was that helpful? Maybe it's not. In particular, let's see how we benefited by putting that line in. Let's try to do the problem again over here. Notice how the x cubes are lined up, the x squares are lined up, the x's are all together, there's only one row of them, and the constants are all together. So you want to do x squared plus 2x into, so we just put it in descending order. We don't put in the missing term. Well, we multiply by x. We multiply what I just put brackets around by x, and we get x cubed plus 2x squared. And we want to subtract. And this is where we run into a slight problem. The x cubes are the same, but now those are not the same. Okay? If it were x squared plus 2x plus 1, when I multiply it by x, I would even get plus x. These are not the same. And that's why we prefer to fill in the missing term. That way things get lined up correctly. You can't do 4x minus 2x squared. And if you did, you better get minus 2x squared plus 4x. It's awkward. The way we did it, the x squares were right underneath one another, which is good. Okay. You need to write the denominator on the outside of that configuration that we do. If you have a divided by b, the b goes here and the a goes here. And a and b are polynomials, okay? That is, you put a polynomial here, and you put a polynomial in here. In here, it should be in descending order with no missing terms. That is, fill in the missing terms. Over here, you can have missing terms. But it should be in descending order. Okay. Let's move along and let's talk about solving or dividing using what's called sympathetic division. If you had x cubed plus x squared plus x plus 1, and you wanted to divide this by x plus 1. Synthetic division only works when the denominator is in the form of a number times x plus another number. Our a in this case is 1. That is, it won't work when it has a square term like 3x squared plus 7, or 3x squared plus 2x plus 7, or an x cubed, or an x to the 4th. That is, the degree must be 1. The degree must be 1. A number times x plus a number. Now, how you do synthetic division is interesting. The first step is you find out what makes that 0. When is x plus 1 equal to 0? And that number is negative 1. That's the number you put in front. The numbers you put under the bar is everything you would write if you put in the missing terms except not the x's. That is, just the coefficients. You have, I'm reading the top line here, the numerator. You have 1x cubed, you have 1x squared, you have 1x, and the constant is 1. If any one of those were 0, I would have put 0 down. Now, I like to put a 0 here, and you add the 1 and the 0 and you get 1. Some people would say, just bring that down. I prefer to think 0. Okay. Now you multiply these two numbers and you put that result there, negative 1. Up and down, you always add. 1 plus negative 1 is 0. You multiply these two numbers, you put that result there, which is 0. You add 1 and 0, you add these two numbers, you get 1. Negative 1 times that number is negative 1. You add. That last number is the remainder. 0, coincidentally, is the remainder. Okay. Let me erase part of this so it might be clearer. Okay. This is the constant term. That's the x term. So we have 0 x's. And here's x squared. So the final answer is 1x squared plus 0 x's I won't write, plus 1. So that's the answer. When you divide these two, you get x squared plus 1. That's the answer. There isn't even a remainder. Let me say it again. The remainder is 0. Let's try another one. Synthetic division is probably easier, but you can't do it with all division of polynomials. The denominator must be linear, must be the first degree. Suppose you have x to the 5th minus 1, and you want to divide by x minus 2. Okay, first step is what makes that 0? The answer is 2. What goes under here, since the numerator, the degree is 5, you put down how many x to the 5th we have, how many x to the 4th, how many x cubes, how many x squares, how many x's, and how many constants, which is -1. I like to put 0 here. Add these numbers, get 1. Multiply and put the answer there, 2. Up and down you add. Multiply, put the answer there, which is 4, excuse me. 4. Add these numbers, put the answer there. 2 times that number, that goes here. Add, get 8. Multiply it by 2, get 16. You add, you get 32. Multiply by 2, you get 64. You add, you get 63. 63 is the remainder. Okay, let me erase some of this, please. Okay. We isolate the constant so it makes what I'm about to do a bit more clear. That's the remainder. Constant, x term, x squared term, x cubed term, x to the 4th term. That is 1x to the 4th, 2 is understood to be plus 2x cubed, 4 is plus 4x squared, plus 8x, plus 32, 63, our remainder is constant, 63 divided by what we're dividing by, x minus 2. Here, the 1 you don't need in front. 1 times x to the 4th, x to the 4th. That is what the top line equals. This is equal to that. And synthetic division gets it to us pretty quickly. Pretty quick. Let's try another one. How much is 3x to the 4th minus 2x squared plus 5x plus 9 divided by x plus 2. Well, what makes this denominator 0, what makes the denominator equal to 0 is -2. That's the number I put in front, -2. And in the numerator, since the numerator is degree 4, though I won't write this, but formally, I better have an x to the 4th term number, an x cubed, an x squared, an x, and a constant. Well, we have 3x cubed reading from the top. We have no x squares. we have negative 2x squared, we have positive 5x, and we have plus 9. Okay, this isn't really here. But you have to put that 0 in. Okay, and I like to put a 0 here. Either you bring down the 3 or you add those two numbers, which means you bring the 3 down. You multiply, that number goes here, and then you add, get negative 6. You multiply, that's 12, you add it there. That adds up to 10. You multiply, the answer goes there, negative 20. You add, you get negative 15. You multiply these two, you get 30. You add, you get 39. Let me just try something, please. Okay, fine. So this is correct. And again, to make it a little cleaner looking, let me do some erasing down here. Okay. Well, that's the constant. This is the remainder. Constant, an x squared, and an x cubed. This last line gives you the division answer. It's 3x cubed minus 6x squared. The 10's understood to be plus 10x. And the remainder, and the constant is minus 15. In our case, plus, could have been minus 39, plus 39 divided by what we're dividing by, x plus 2. And how you would check this is like any division. If you took this, we claim it equals to 3x cubed minus 6x squared plus 10x, take away 15, plus 39 over x plus 2. Well, if you took x plus 2 and you multiplied it by that mess, you should take the top. Just like if 2 into 8 is 4, well, 2 times, to check, 2 times 4 is 8. Somebody asked you what 8 divided by 2 is. You do 2 into 8 and you get 4. 2 times 4 should be 8. Now, synthetic division can help you with another thing. This might be real helpful for a long time to come, for the rest of your life. As long as you need to evaluate functions, you can use this new trick. If you're asked to find, suppose I tell you that f of x is equal to 2x to the 4th minus 2x cubed plus 4x minus 9. And I ask you to find f of 3. Well, you'd have to do, one way is to do 2 times 3 to the 4th minus 2 times 3 cubed plus 4 times 3 minus 9. So we need to find the values of these terms, which we'll subtract and add. 2 times 3 to the 4th. Well, 2 is 2, and 3 to the 4th is 81. When you multiply them, I guess you get 162. 2 times 3 cubed. 2 is 2, 3 cubed is 27. 2 times 27 sounds like 54, and those were 2 separate terms, excuse me. 4 times 3, and then 9. Then you add 4 times 3 is 12, and then you take away 9. And this Subtraction gives you 108. And you add 12 and take away 9. Well, 108 plus 12 is 120 minus 9 is 111. Okay. There's a much easier way to find f of 3. Do synthetic division with 3 in front. And whatever the remainder is, that's going to be f of 3. So, it's 2x to the 4th. I'm writing down f of x, but I'm filling in missing terms. 2x to the 4th, negative 2x cubes, no x squares, 4 x's, and a constant is negative 9. And I was off a little. Okay. I like to put a 0 there. You add these numbers, you get 2. 3 times 2 goes there. You add these two numbers, you get 4. 3 times 4 is 12. You add these two numbers, it goes there. 3 times 12 is 36. You add these, you get 40. 3 times 40 is 120. You add these two numbers, you get 111. That's f of 3. The remainder is 111. So you never have to do function evaluation anymore. You never ever have to do this ever again. Just do synthetic division. Let's try another one of these. If I tell you that g of x is 7x cubed minus 2x squared plus 3x. And I ask you if g of x is that, then find f of negative 3. Find f of negative 3. Well, you put negative 3 in front, put that number in front, and then you put g of x under the bar. You can't miss terms. That is, g of x has 7x cubes. It has negative 2x squares. It has 3x's, and the constant is 0. And I like to put 0 here. You add these two numbers, you get 7. You multiply, that's negative 21. You add, that's negative 23. You multiply, guess you get 69. You add, that's 72. You multiply, and you get negative 216. And you add, and you get negative 216. Minus some silly error. That's g of negative 3. That is, if you plug negative 3 in, and you computed this mess where x is now negative 3, you will get negative 216. Powerful stuff. Let's do one more division. Suppose you were asked to do x cubed plus 2x squared minus 7x minus 4. You want to divide this by x plus 5. You can do this by long division, and since the bottom is linear first degree, you can do it by synthetic division. In fact, since we haven't done it yet, what if we have a number other than 1 in front of x? What if we have 2x plus 5? Well, we need to find out when that's 0. And it's going to be 0 when that's negative 5. Negative 5 plus 5 is 0. If you don't believe me, here it is. 2x is negative 5. Divide by 2, we have x is negative 5 over 2. Maybe not the friendliest number to put in front. It's negative, it's a fraction, but that's what goes in front. What goes under the bar? The numerator, highest degree is 3. we put how many x cubes we have, we put down how many squares, x squares we have, how many x's we have, and what the constant is. Then we bring down the 1. 1 plus 0 is 1. Negative 5 halves times 1 is negative 5 halves. We have to add them. That is, we have to compute 2 minus 5 halves. Well, 2 is 4 halves. 4 divided by 2 is 2. 4 minus 5 is negative 1 halves. Okay, when you add them, you get negative a half. What do you get when you multiply that? Well, a negative times a negative is a positive. 5 over 2 times 1 over 2. 5 times 1, 2 times 2. It's 5 quarters. That's what I put here, 5 quarters. Negative 7 plus 5 quarters. Well, you need to write 7 with a 4 in the bottom. Well, 7 or negative 7 is what over 4? Well, 4 times negative 7 is what goes there. It's negative 28. Plus 5 is negative 23 over 4. That's what goes here. Okay? Now we have to multiply negative 5 halves by negative 23 quarters. Well, let's erase our side work and do that. If you think this is hard, fine, it's hard. But, okay, so we're doing a division problem. But using long division is going to be much, much harder. So we need to multiply or compute negative 5 halves by negative 23 quarters. Well, first, do the sign. A negative number times a negative number is positive. Good. There are no signs. The answer is positive. 5 times 23 is that number. And 2 times 4 in the bottom is 8. That's what goes here. 115 over 8. Now we add those numbers. I want to write negative 4 with an 8 on the bottom. 8 times negative 4. That's what goes there, negative 32. So if we think of this as negative 32 over 8, and we add 115 over 8, the denominators are the same, and we will get 83. 83 over 8. 83 over 8. Okay. 2 things I want to comment on. Or I want to teach you one thing. If you have a fraction, you have A over B, whether they're easy looking or complicated looking, whether A is easy, hard, B easy, complicated looking, doesn't matter. We divide it by C. How does this simplify? Well, you have every right to multiply the top and the bottom by the same value. Say B. A over B times B, the B cancels out to it, and you just have A. On the bottom, you get CB. Now, how can we look here and get there quicker? Answer. What can we do to get here quicker? Answer is, that is, instead of doing this middle step, the answer is just bring the denominator to the other denominator. So somebody asked me, what is 2/3 divided by 5? I would immediately say 2 over 15, because the 3 and the 5 go together. They get multiplied together. And of course, 3 times 5 is 15. Okay, I think we're going to use that. And the 2, 3, and the 5, or the A, B, and the C, don't have to just be numbers. They can be more complicated than just numbers. If you understood what I said, And you don't have to understand it right now. At some point, if you understand what I'm saying, it'll make this type of problem easier. This number, that's the constant. This number is the number of x's, and this number is the number of x squared. So I know that that fraction on top is equal to 1x squared minus a half x minus 23 over 4 plus the remainder, 83 over 8, that's like my a over b, over what I'm dividing by, namely 2x plus 5. All I'm suggesting is that you clean up that last part. You can bring this denominator up with the 8. That is, it's 83 over 8 times 2x plus 5. You need to know, like you know your name, a divided by b. If you now divide that by c, this is the same as a over bc, or a over cb. That is, this denominator goes there, or if you prefer, the b goes to the bottom. They get multiplied together, and they stay in the denominator. Okay. Okay, that finishes this section.